Does anyone feel like this represents their morning commute? Oftentimes, when we're driving and we get into a traffic situation, there's simply no way to tell what's happening in front of us. But with IntelliMagic Vision, we're able to actually look downstream and see if there's any bottlenecks that are happening downstream that can impact performance on the host side. And that's what we're going to look at in this example. In this view, you see the IntelliMagic Vision Node Performance Dashboard for IBM SVC. This dashboard provides an overview of the performance health of your IBM SVC environment based on ratings of the health of the key risk indicators. And along the y-axis, it's going to show the different SVC and V7000 clusters. And along the x-axis, it's going to display the key risk indicators. Blue dots represent relative I/O busyness, green dots represent areas of low availability risk, and yellow dots represent some availability risk, while red indicates significant risk to availability due to performance constraints. So as you can see, there's three different clusters: East _ SVC 001, South _ SVC 001, and West _ SVC 001. For this exercise, we will focus on the issues with South _ SVC 001. For South SVC 001, we have significant risk as indicated by front-end read response time, read hit percentage, and front-end write response time. By selecting the time charts in the drill down options above the chart and clicking anywhere in that row, we're going to take you to a more detailed view of the risk over time. This set of charts is great for identifying if there's any correlation between various key risk indicators. Within each chart, there is a line for each node, and most of the charts are pretty busy, so it may be hard to see the correlation. The outline colors for the rated charts follow from the dashboard. Notice the red for node read response time. Within the chart, notice the gray line. By clicking on the node read response time chart, we bring this chart into view and identify nodes with high response time. Notice in the legend there are several SVC nodes that are in bold. These all contain a rating value that's high. The higher the value, the higher the risk. In this case, South _ SVC _ 7 RW GNA _ N7, which I'm going to refer to as node 7 throughout the remainder of this case, has the highest rating at 1.71. We're actually going to look at which volumes are affected by this, so we're going to click on the line representing node 7. This chart shows the front-end read response time for the top 30 volumes on node 7. There's only two volumes that show in bold in the legend. The volume labeled volume -000006, forthwith referred to for obvious reasons as volume 6, has a rating of 1.97 and is highlighted in bold. This is the highest rating and the highest risk of performance impact, and it's the biggest reason why node 7 has a high rating overall for the front-end read response time. By selecting Isolate in the drill down and clicking on volume 6 in the chart, we're actually going to bring a new chart which we'll show in the next slide. It's easy to see why this volume has a high rating. The read response time for this volume is greater than 100 milliseconds at times. In order to better understand the root cause, I've customized the chart and added the read-miss IOs per second. And you can see there's a very high correlation between the response time and the read-miss rate. This means that the majority of the response time is related to back-end service time and queuing. And in order to better understand what's happening on the back end, we're going to take a look at the storage pool by clicking on the Identify Drill Down button. Looking at the volume properties, we see that volume 6 belongs to the South _ DSS _ Tier 2 _ 01 storage pool. Now let's take a look at the back-end performance of this storage pool. As you can see in this set of multi-charts for South _ DSS _ Tier 2 _ 01, there is lots of queuing and high response time for this storage pool. The queue time is greater than 100 milliseconds at times. This explains the high front-end read response time in conjunction with the read-miss IO rate. So very similarly to when an accident on the freeway that is miles ahead can cause slowdowns where you are at, when you have a downstream bottleneck on the SVC backend storage, you're going to experience high response times on the front end particularly when there's a high number of read misses. So how do you deal with back-end congestion? Well, there's several approaches. You can add more lanes to the freeway, such as adding more MDIS or disk drives. You can also add faster lanes, for example, adding flash. This is most helpful for small random read workloads. And you can slow down certain workloads with I/O governance or I/O limiting. You can also add an HOV lane. The equivalent would be I/O priority queuing. Currently, it's available in the DS8000, but IBM has requested that it be standardized in SCSI T10.